to make a small project just to know how to use KiCad to design a PCB. Okay. So I'm gonna start from scratch. I'm going to close everything. So first thing, I will type just KiCad. So when you open KiCad, there's already a project I have before, so I'm gonna close this project and make new project. So when I make new project, it will ask me firstly, where would you like to keep this project? Okay, so select one of the places in your computer. So I'm gonna select or make new folder on desktop, for instance, here. And I will say, for instance, PS, power supply. So let's make a power supply, small power supply today. And the file will be also PS. So once you do that, you will find here you have two main files, which are schematic and the PCB layout. So these are the two important files we need to use in order to design our PCB. So let's firstly start with the power supply. What are the components, guys, of the power supply? What are the main components of a power supply? So I need to make power supply of 5 volt plus 5 volt, and the current is, let's say, 1 ampere. So how can I do that? What are the components I will need in order to make this power supply? We need rectifier, okay? We need capacitor filter, okay? Voltage regulator. What's else, guys? Zener diode for what? But Zener diode is doing the regulation function. But since we have regulators, so we don't need in this case Zener diode, because the Zener diode circuit will have a very limited current compared to the high current power supply. Okay, because for a Zener diode, you have to have a series resistance, correct? And if you have high current, this series resistance has to be high power. Okay, which is expensive, generating a lot of heat, and not recommended. So instead of using Zener diode, we can use regulator instead. Okay, so the regulator can solve this problem. But we still need transformer, correct? Transformer to step down the volt from 110, for instance, to, let's say, 6 volt. Okay, so 6 volt, I believe this is the lowest volt you may find in transformers. I'm not sure if you can find less or not, but 6 volt is enough to have +5 DC link or not, or +5 DC supply or not. So you remember that if you have full bridge rectifier, the peak value of the volt will be, or the maximum DC you can get is the peak value of your sinusoidal supply. So if the sinusoidal supply is 6 volt, what would be the peak value? 6 times √2. Okay, so 1.4 times 6. So it's around 8 point something, I believe. Okay, so this would be the peak value now. So 8 volt, yeah, can be regulated to 5 volt easily. Okay, so let's find how can we make a circuit like that. So I'm gonna start with the schematic. So I double click now on the schematic file. So this is the schematic sheet I have now. Firstly, I would like to get the components. So let's look for the component. The component is coming from the library. So here you can find place and add symbol. So the component is nothing but some symbols here. So symbols will be added together. Make a connection between these symbols. So this is gonna be your schematic. Okay. So firstly, look for a transformer. So I'm gonna add simple, will open the library to me. Still loading. Okay, so this is my library now. I need to find transformer. So let's type transformer. Okay. So I could find here transformer, single primary, single secondary. But do you see any footprint for this transformer here? We don't have footprints, which means it's better to find a real transformer from the market and start using that in order to have the correct terminals, the correct size in case of footprint, and so on. So what we can do is, let's look for a transformer firstly on companies, suppliers of electronics, and grab this transformer and see if it is exists in our library or not. If it exists in the library, this is fine. If not, we need to add it to our library now. So let's see together how can we do that, guys. So I'm gonna go to any, let's say to Mauser, for instance. So Mauser Electronics, and I will search for a transformer. Actually, I had a look for this transformer. So here, for instance, this transformer is, I'm gonna open the data sheet. So this transformer here, this is the shape of this transformer, and it has been mentioned here, 3 flange dual primary, 6 volt ampere. So 6 volt ampere, if the secondary is 6 volt, so the current will be 1 ampere. So this is fitting my requirements now. I need to have 1 ampere DC power supply. Okay, so let's get this transformer. Actually, you will find some data here for that transformer. So for instance, we have parallel or series. Parallel or series, why? Because we have many windings. It's not single winding. So as you can see here, we have 4 terminals for the primary side and 4 terminals from the other side. So as you can see here, 1 to 4, and from the other side, we have 5 to 8. Okay, so we have 8 terminals. So we expect to have many windings now in primary side and in secondary side. So if you have a look here, this is the primary input. So we have 2 coils. If you would like to have 115 volt, so connect 1 and 3 together, 2 and 4 together. So this is in case of 115. If you don't like to have 115 and need 230 volt for primary, so connect 2 to 3. So this would be the way of the connection in order to get 115 or 230 volt. And for the secondary side, we have also parallel or series. So the parallel connection will make the volt to 1/2 of the series connection. So what the volt is, we can see that from the table here. So you can find here from the table the AC volt of the parallel connection. So this is the secondary. So you can have 5 volt and the current would be 1.2. So this is for parallel connection. So 5 volt is the secondary. Is it enough to have 5 volt DC or not? So for sure, 5 times root 2. Okay, so this means it's very suitable for the 5 volt power supply. Okay, so I see this transformer is fine to make a power supply of 5 volt. So what's the next step? Next step is to go to the library here. I'm gonna open this product now. Okay, so this is only the shape. Where can I open the item page? Okay, so it seems we don't have another page in Mouser. Okay, but if I would like to get the library of this one, firstly, I'm going to take the manufacturer number. What the manufacturer number here? This is the manufacturer number. Can you see this? Sorry, this is the part number of Mouser. This is the manufacturer number 3FD436. So I'm gonna copy this and check if I have this in my library or not. So go to KiCad again and type this number. Actually, it's here. Okay, it's here in my library. Okay, but I added this transformer. It was not there. So let me show you how can you add a component to your library. So I'm gonna assume that I don't have this component now. What I can do is I got the number. I need to install in my computer a program called library loader. So in the library loader, you can upload the 3D printing or 3D print out for any element. 3D means you can have the 3D shape, you can have the layout and symbol, both or all three items will be in this design. For which program? Actually, they made it for almost all of prototyping programs. So one of them is KiCad, so you will find KiCad in this. So the first thing is I need to browse the project place. So the project place, I made it on desktop, for instance. So this is desktop and the folder name is PS. So this is the folder name. And inside that folder name, I'm going to create a new project and I will call it library, LIB. And I will use this folder. So this folder will include any components I need to have it in my project. Any component not exist in the library and I would like to add it. Then go to search for parts. When you press on search for parts, it will go to this website. Firstly, you need to create an account. So as you can see here, my name is written here. So this means it's already logged into my account. However, for you, you have to create account firstly. And this is free, okay? So make the account and then I'm gonna type the number here and search. So as you can see here, guys, this is my transformer. And here you can download the model. So let's download the model now. And again, I will download the model in the folder I created for my project. Okay, so desktop again, power supply, library, and then I will save this here. Next step is to go to the library you created. So PS library, you will find the zip file. You need to extract this file. So I'm going to extract here. Okay. And then I need to have the symbol and everything for this transformer. Inside this block, you will find the KiCad. So here you have the symbol, you have the library. So everything is defined here in this library. So you can include this in your model now. How can I include that in my model after downloading? So go to your project again and go to preferences. Firstly, I'm going to add the symbol. So symbol and open. Then go to the place again of your library on the desktop, power supply, library. This is the number I need. And then go to KiCad. So you will find the symbol. So I'm going to add now this symbol. Has been mentioned here, it's already exists because I show you firstly, I have this. but when you make it, it will not provide this message for you, okay, because you don't have this in your software, okay? So I'm going to skip this one now and press OK. This is number one. Number two, I need to add the footprint. So by the same way, footprint and then open and find the place again, desktop, PS, library, and look for KiCad. Select the folder. So he mentioned to me here, KiCad was there already. So let me delete this one, and I have it here already. So I'm gonna press OK now. Now, go to here again and add this component. So if I press A, it will open the library and then type the number. And as you can see, this is here. So double click here, and this is your transformer. Okay, so you don't need to create new elements. Just download the library. Only if it is not exist, if the library is not there, you may ask the company to provide you with the model so they can create the model and send it to you, or you can create your own. Okay, you will find a lot of YouTube videos. How can you create a new element or component in KiCad? So in this case, you have to create a symbol and create a footprint as well. Okay, which for sure consuming time, but if you can find something equivalent, okay, so you can use it instead. Okay, nice. So I added now the transformer here. If you double click here, guys, on this element, so here this is the reference, this is the value, the footprint is already there. Okay, so I'm gonna press. Okay, so he said to me this is not a valid library number. So let me find the library. Where is the library of that? So I'm gonna search on the library here. So I'm gonna press or paste the number again. So it seems it's not here. So it's not uploaded from the software. I don't know why. So let's look for it again, guys. So for sure, these are not our transformers. So what I'm gonna do now is adding this library. So it should be in KiCad. Yeah, this is the one. Okay, so it's appeared here to me. So this is the one I have. So I'm gonna press now OK. And now if I would like to go to the layouts, it should be there. So I'm gonna save now. And from here, I can press on Open PCB Board Editor. So if I do that, will open the library, and I can get the component once I press here, Update PCB. So once I update, it will give me this message. I have no errors, so I will just press Update the PCB and close. So you can now drag your transformer. So can you see, guys? We could have now the library. We have the symbol and the footprint as well of this transformer. So this is in case of missing anything in your library. Okay, just make an account in the website I show you, and then download the file you need. Okay, so this is a transformer. Next step, we said we need diodes or bridge rectifier. For myself, I see bridge rectifier is expensive and not durable compared to diode. In case of small power, what we need, okay? Why? Because what happens if you lose one of the internal diodes of the bridge? You have to remove all the bridge, correct? But if you have diodes and you got one damaged diode, so you can replace just one diode, and it's very cheap, by the way. Diodes are very cheap compared to the bridge rectifier. So I do prefer to have the single diode and have 4 of these diodes instead of getting the full bridges. This is one thing. Another thing is the 4 diodes on your board will take less size compared to the bridge, okay? But it's up to you. You still can use whatever you want. So I'm gonna press again to open the library. I pressed A. So once you press A, it will open again the library to you. I need to get diode, so I will just type diode. So you will have all of diodes you need. If you know a certain diode number, you can type the diode number. For instance, we used in our lab 1N. You remember 1N 4002? Okay, let's type that. So 1N 4002. Okay, so this is 100 volt, 1 ampere. It's okay, 100 volt, 1 ampere. However, do we need 100 volt? 100 volt is relatively high for our circuit here because the output volt of the transformer is just 5 volt RMS. So let's find less volt. For sure, it will be less expensive. Okay, so instead of that, let's look for the other diodes we have. Okay, so let's see here, guys. Let's scroll down and find the different voltages we have. So we have different voltage values here. Let's see something around 20 or 30 volts. Okay, so we can find here, this is, guys, 20 volt, 1 ampere Schottky barrier rectifier. Can you see, guys? This is just one diode, 20 volt, and this is Schottky, by the way. We discussed it before on the meaning of Schottky diode, correct? So what's the difference between Schottky diode and regular or general purpose diode? Reverse biased, or this is Zener diode, not Schottky diode. What about Schottky diode? Do you remember, guys? Not the voltage, the delay time, which makes this diode fast, and you can apply it for high frequency applications. Okay, so for general purpose diode, you cannot apply it, for instance, with the rectifiers, controlled rectifiers, or inverters circuits with relatively high frequency, like 20 kilohertz, for instance. Okay, so it will not turn on and off quickly like the Schottky diode. So we have to use Schottky diode in this case. So in the power supply, actually, we have only frequency of 50 or 60 hertz. Here in the United States, we have 60 hertz only. However, using high frequency is not going to make any problem with us. So you can still use this Schottky diode. So I'm gonna select this one, guys, now. So once I select the diode, by the way, I can press R on the keyboard to turn it right or left or rotate, okay? So this is diode. Let me now double click on this. Double click on the diode to see if I have everything. Actually, the footprint is there, so I don't need anything now. It will be added automatically to our layout, correct? Okay, so how many diodes I need now to make a bridge? I need 4 diodes, correct? So I can copy and paste this. Okay, so these are the diodes. What else, guys, we need? Capacitor. Let's start with the capacitor. For sure, you have a relation to calculate the capacitor based on the desired voltage ripples, correct? So you can use the relations we discussed in our class to get the capacitance value. For instance, here I'm going to select a capacitor, but I will leave the capacitance value for you. So again, go to the library. I'll press A. to open the library and just type cap. So we have many capacitors, guys. Which capacitor we need to use? We need to have electrolytic capacitor, guys. Okay, regular electrolytic capacitor. So let's look for the electrolytic capacitor. The word capacitor. So we have switched capacitors. We have a lot of types of capacitors. By the way, we have here polarized capacitor. So what's the meaning of polarized? Polarized means it's AC capacitor. So it can be connected either ways, correct? But this is not the one we need to smooth the volt. We need DC capacitor, correct? So we have like generic unpolarized capacitor here, okay? But it has no footprint. So we need to select a footprint later for this capacitor, for instance, okay? If you would like to get it again from the library, so by the same way, you can look for it from the library. Let me go and find that with you very quickly. So again, on Mouser, I'm gonna search for capacitor, 20 volt, 1000 microfarad. I'm just writing any roughly value. Let me. Here. Okay, so we need electrolytic capacitor. This is the one. We have aluminum electrolytic capacitor. Okay, titanium capacitor, but this is relatively expensive, I believe. And we could find here 20 volt DC, but it's axial capacitor. It's not radial capacitor. Okay, let's find another radial capacitor, or let's see what we have here. So we have here, but it's non-stock, guys. So if it is non-stock, don't get it, because you cannot find now in the market. Okay, for sure, when you look for anything, you have to check the in stock in order to get the capacitor. Okay, otherwise, after making your design, you may not get these components. Okay, so all of these are non-stock capacitors. Okay, let's look for different value for the time being. Instead of 1000, let's say capacitor. Just general capacitor, and then select between what we have. So aluminum electrolytic capacitor. And we can select now what we need. So we have radial capacitor. We can select the volt. So let's say the volt is 20 volt, for instance. Okay, and we still have 198 after applying this filter. So let's make more filtering to get our capacitor. So where is the capacitance value? Is it mentioned anywhere here? Okay, so here, let's look for the capacitance value. We need, okay, we have, for instance, 560 microfarad. Apply the filter. So we have here some components, okay? So this is a capacitor shape we have. Do we have the 3D model? Let's look for the 3D model here. I'm not sure if we have these models or not, but let's look for that if we have that model, guys. So let's copy. For instance, this is polymer capacitor, 20 volt, 560 microfarad. ESR, guys, is equivalent series resistance. Okay, so ESR 12 milliohm, which is fine. Okay, so let's take this part number, manufacturer part number, and look for if we have this model or not. Okay, so I have it here, so I can download this model now. So I will download it to the same place. So this is my library. I will download it here and then go to extract. So let's extract this here. And then add it again in our library. So I'm gonna close that and again go to the main project, references, manage symbols, open, and go to the library. This is a capacitor. Go to the KiCad and then add the symbol. And by the same, I should go to the footprint, add the footprint for this one. So go to KiCad. Okay, but let's give it a name or of KiCad like 2. So let's make it here KiCad 2 because we have this name before. Otherwise, guys, we need to have all symbols on the same library. So let's select this folder and press OK. So now I have everything. Let's go and include this in our schematic now. So if you press add component, type the capacitor name, you will find it here. Seems it's not appearing yet. Let's check, guys, again. Okay, so it has a different name. So this is the name. We need to get the name of this one. Okay, let me delete it now. And for this one, let's copy the name and press OK. Go to our schematic, go to library. I don't know why it's not there. Something is wrong, guys. something is wrong with this element. Maybe some files are missed in the library itself. Okay. So for the time being, let's add this capacitor, any regular capacitor. But this is the way, guys. Sometimes you may not have the complete model from the companies, so you may have some problems. But let's now have any other capacitor. Okay. So I'm going to select any unpolarized capacitor. So this is polarized polarized capacitor, guys. It's DC. Am I mentioned polarized AC or DC?
The polarized was AC.
No, sorry, polarized is DC because it has polarity. Unpolarized is AC. Okay, unpolarized means it can be connected any way, okay, by any way, but polarized is DC. So we need to select polarized capacitor. So I'm gonna select any polarized capacitor for the time being. Okay, so this is a polarized capacitor here. Okay, and I will select a footprint for that one. So after double clicking here, just go to footprint and select one of the footprints which matches your capacitor. So let's type capacitor. Okay, and you can find all the capacitor dimensions. Even if you couldn't find the exact capacitor, you can select the equivalent footprint. Okay, so let's select one of the footprints here, but I need to have the axial, sorry, the electrolytic, not surface mounted, the regular one. No, it's not this. Okay, I selected here SMT. I need throw hole, guys. Okay, so this is the throw hole. Okay, and here you can find the axial. So all of these are axial capacitors. You will find the radial as well. Okay, so these are the radial capacitors, for instance. So let me, for instance, select this one, and the dimensions will be there. Okay, so you will see the dimension and just press OK. So now I selected the capacitor and the bridge. What else? What do we need? What more elements, guys, we need here? The voltage regulator. So let's go to voltage regulator. So I press A again. The voltage regulator we need is 7805. So this is the number of this regulator. Okay. So we have a certain one with the footprint. So this is ready one here, guys. So TO220 is a well-known case style for transistors and regulators. So let's select this one, and this will be our regulator. For power supplies, guys, we do prefer to have a capacitor after the regulator as well. This helps to keep the volt more regulated. Okay, so I'm gonna duplicate this capacitor. So we have capacitor one here. I will add it also after regulator. This is one thing. Another thing is, if your power supply is gonna supply some high frequency loads, like microcontroller, for instance. So you expect to have some ripples coming from the microcontroller, some high frequency ripples. So we do prefer to have a filter for high frequency as well. So filter for high frequency means capacitor in picofarad, not in microfarad. So let's add another capacitor in picofarad. So I'm gonna add one small ceramic capacitor. So let's say ceramic capacitor. Okay, it's not here. Let's get it from capacitor. Okay, and look for high frequency capacitors. Okay, so I couldn't find, so I will select the unpolarized capacitor, and I will add a footprint according to what I can see from the market. Okay, so this capacitor is regularly very small surface mounted capacitor. So I'm gonna add this here and double click on the element itself and select your footprint. So go here and press on the footprint library and try to get the footprint of the suitable capacitor. So get it from the capacitor SMT, and you can find any, yeah, like 0805, for instance. So this case style will be available a lot in market. So select one of them just to make your capacitor. Now, do I have everything ready, guys? I have all of the components now, correct? Do I need any other thing to connect this power supply to source and load or not? Exactly, pins or connectors, correct? So let's look for terminal block. So press A and look for terminal. So you can find here screw terminals. How many pins we need? How many terminal we need? We have 2 terminals for AC, 2 terminals for DC. So let's select 1 times 4. So 1 means 1 row, times 4 means 4 terminals. You may find 2 rows with different terminals. It's up to you, okay? Here for us, it's sufficient to have 1 row for terminals. So I'm gonna select that and add it here, and also look for the library. So in the library, in the footprint again, press here and look for the terminals. So I'm gonna write terminal here and find the terminal block. So for the terminal block, guys, you can find a lot of terminal blocks, and it's defined by the distance between the 2 terminals, okay? For instance, this is 5.08 millimeters. So this means the distance between 2 terminals is 5.08 millimeter. But we need 4 terminals, so let's select the 4 terminal blocks. So this is our library, and press OK. Yes, pins or screws, it's up to you. Screws better for high power, but the high power means how much distance you have between your terminals. So for high power, guys, we have a relation between volt and distance between terminals. So you know that for 1 kilovolt is sufficient to make break or ionize air within 1 centimeter. So if you have 2 contacts and the 2 contacts in a distance of 1 centimeter, and you applied 1000 volt, this is gonna flow current in air. Okay, so this is going to polarize the air and flow current between the 2 contacts. So you have to keep a certain distance according to the voltage magnitude you have. Now you have 100 volt or 110 volt. If we assume the relation is linear, so 100 volt needs like 1 millimeter, like that. Okay, so 5 millimeter is more than enough for the 220 volt, for the 115 volt, guys. Okay. So now I believe we have all of our components. So the next step is let's make our schematic, connect the schematic, what we have here. I think the class will not be enough to make everything today. So we will try to finish the schematic or part of the schematic today. And next class, we will go in the other part, which is the layout. Okay, so let's start with make the connection now. Now, I'm gonna rotate this just to have it like that. So how can I make the connection now? We mentioned that in order to make this transformer, you need to connect 1 and 3 in parallel, correct? So let's make now wire. So I'm gonna press here to add wire, okay, or press W. So 1 and 3 will be one terminal, and you can connect this to terminal number 4. And 2 and 4 will be one terminal, and connect this to terminal number 3. Now let's connect the rectifier. So here also we need to connect 5 with 8, sorry, 6 with 8, and 7 with 5. And then this will be the positive, should be connected here, and this will be the negative, should be connected here. And now connect between the diodes in your bridge. Sorry, the negative should be connected here, but let's run this line like that. And here, this is the positive terminal. This is the negative terminal. Then let's connect our capacitor. Our regulator. So this is a voltage regulator positive terminal. This is a ground terminal. And this is the output, can be connected here to this capacitor. And then this would be the output volt. So we can connect now the output volt to our connector. So let's connect this to the ground. And this terminal, let's press W. To this terminal. We forgot to connect the capacitor, this capacitor. Let's move this capacitor here. And this is the positive terminal. This is the negative terminal. So now schematic is ready. However, if you are going to make simulation, you have to add power supplies. So now you have terminal, correct? The block terminal, which will be connected in reality to your system. But if you like to make simulation, you have to have your supply, your exact supply, in order to be connected to your ground, connected to the AC source, and so on. Okay, so what I'm gonna do is I'm gonna define some power terminals, which will help me during the PCB layout. So how can I do that? Go to place and then select add power, or just press P. And on power here, guys, you will find the different power levels. So I'm gonna select +5 and we'll connect this to this point, and ground to be connected to 0 level. So here you have ground, okay? So ground will be connected here to this terminal, and then make the wires between the supply terminals. Okay. So this is now our schematic. It's ready for the next step, which is layout. Next class, we will discuss together how to make the layout on it. Any question, guys? Much, and see you next class.